If you can't recompile your program to insert the canaries, then there is the possibility that a buffer overflow writes a return address that jumps to some other part of the code that does something it shouldn't do at this point. We can at least make this harder by not making the address of that code easy to predict. Address Space Layout Randomization, or ASLR, is a feature of an operating system that when it runs a program, it loads the code to run that program, then it puts the code in a different place every time you run. It turns out that compiled programs don't expect to be run in one particular place for the code. They allow the code to be moved around, and ASLR takes advantage of that at the operating system. So it prevents the easiest kind of buffer overflow attack, where you write an address over the return address that is some other part of the program that you're attacking. And again, it has the advantage that you don't have to recompile your existing program to make use of this. And so that's why it's on and enabled by default on all modern OSs. And you can see it in action if you have a little program that just prints out the address of main. So I've got that program here as here.c. If we compile it and run, then it turns out that is where main was loaded this time that the program is run. But if I run it again, then it's at a different address. You can see that the low bytes of the address stayed the same, and it will stay the same every time I run it, and that's because the randomization happens at the page level. Relative to its page of memory, it's always sitting at the same place, but the virtual address that is used for that page of memory can be different every time the program is run. That's true for code, like main. It's also true for the stack. So if we make a buffer here, and instead of filling in that buffer, I pass the address of that buffer to printf to print it out, then we will again see that the buffer has a similar location every time it's run, but a slightly different location, and that is because ASLR is moving the stack around as well as the code each time. All of this is not addressing the real problem that a buffer overflow is possible, that undefined behavior is possible, but it is making it harder to take advantage of mistakes at that level.